All right, friends, let's dive back in. Here's your clue for looking for the highest priority functional group. Again, you can memorize the rules, but the easiest thing is to count the number of carbon heteroatom bonds. Z here equals a heteroatom. By heteroatom, I'm basically meaning anything that's not carbon or hydrogen, particularly an electronegative heteroatom. So oxygen, nitrogen, sulfur, what else am I missing? That's basically it. I suppose you could include the halides, chloride, iodide, etc. Though we won't encounter those a ton in biology. Mostly we're going to see oxygen, sulfur, and nitrogen. Molecules where a functional group has more bonds with a heteroatom and carbon into a single carbon are higher in priority than those that don't. For example, a carboxylic acid, a carboxylic acid or an amide or an ester all have higher priority than a ketone or an aldehyde. Because if you zoom in and look at the carboxylic acid, 1, 2, 3 bonds to an oxygen, 1, 2, 3 bonds. We're focusing in on the central carbon of the functional group. 3 bonds, 2 to oxygen, 1 to nitrogen. Similarly, 1, 2, 3 bonds to oxygen. And if you look at your priority list, all of these are higher in priority than these two, which have one fewer, 2 bonds to an electronegative heteroatom. See that? Now you may wonder, among these, which is highest priority? And the answer is there is a rule for that, but I'm not going to give you a question where you'll have to decide, is it that carboxylic acid or the amide? Because frankly, I don't even know off the top of my head, nor do I care. And I'm not going to ask you to do stuff that I don't care about. So it's fine if you group these in one general category, right? Do you see the difference between these two groups? No? Okay. Let's talk about that. Somebody help explain it. What do you see? Focusing on the carbonyl carbon, we're going to count each bond to oxygen independently. Each bond to oxygen, nitrogen, or sulfur. 1, 2, and 3. This carbon here is bonded 3 times to oxygen, 1 time to carbon. Whereas this carbon here is bonded only 2 times to oxygen, the other time to carbon and hydrogen. So we're ranking these in priority on our arbitrary list of priority based on number of bonds to oxygen. Yeah?
Isn't our group generally not going to be that oxygen?
Right, and I should be clearer about that, shouldn't I? R is usually going to equal carbon or hydrogen, but mostly carbon, some kind of carbon. The second example underneath the 3, what we're looking for is not only, and I should have been clear about this too, thank you, we're looking not only for oxygen, but for nitrogen or sulfur. So there, 2 bonds to oxygen, 1 bond to nitrogen, 3 bonds to a heteroatom total. Yep. Okay, good. And therefore it would stand to reason that an alcohol or a thiol or an amine should be lower in priority than a ketone or an aldehyde Same thing with an ether, actually. It should stand to reason that all of those would be lower in priority because each of these only has one bond between the central carbon of the functional group and an electronegative heteroatom. Now, I'm realizing that drawing the ether is problematic because you're going to look at that and say, which carbon counts the most? I don't actually care. It doesn't matter. We were actually not going to talk very much about how to name ethers because they get kind of confusing. But all of these that have only one bond between a carbon and an electronegative heteroatom are lower in priority than have two, and those are lower in priority than have three. Now, understand by priority, we're not talking about like reactivity or anything other than an arbitrary list that somebody gave us to decide basically which groups we're going to talk about first when we make the name of the molecule. All right, questions about that? So what is the highest priority functional group for the molecule? Carboxylic acid. Okay, good. Now there are two of them. There's going to be a way to deal with that. I chose that deliberately. But the highest priority functional group is the carboxylic acid, and there's two of them. All right. So the highest, let's see. To show you more about how to write a name has several parts. It's got a prefix, it's got a root, and then it's got a suffix. The suffix tells you what the highest priority functional group is. The root tells you the number of carbons. This is technical, but remember these are rules. And if you've ever tried to invent a game with a group of like 7-year-old boys, you realize that it devolves very quickly into what all the rules are, and you never actually get to play the game. And that's what it is here too. We've got so many rules, but we want to be precise. And I'm only teaching you enough rules to be generally conversant. The root comes from the number of carbons in the longest chain that contains, you guessed it, the highest priority functional group. Okay? And it's also going to contain the number and locations of pi bonds, whether they are double bonds or triple bonds. Finally, the prefix is going to summarize everything else, the locations of all other groups. Okay, so part one was identifying the highest priority functional group. Because our highest priority functional group is a carboxylic acid, what is the appropriate suffix for a carboxylic acid? Yeah, if you look at that handout, it is, we'll just use a dash to indicate there's other stuff coming before it, oic acid. Whatever the rest of the name is, the suffix is going to be oic acid. Okay? All right, let's talk about the root, the number of carbons in the longest chain that contains the highest priority functional group. We don't have a lot of other choices here because this is a simple molecule. 1, 2, 3, 4, right? 4 carbons. So what is the appropriate root for 4-carbon chain? Butane, right? If it was 1 carbon, it'd be methane, 2 carbons ethane, 3 carbons propane, 4 carbons butane. After that, it gets easier, pentane, hexane, heptane, and so on. And if it gets longer than that, if it gets longer than octane or nonane or decane, we generally don't care anymore, and we give it some other name. Okay, so this would be, it's going to have the basic root butane. Now, we need to pay attention to that ane portion. At this stage, we want to ask, are there any carbon-carbon pi bonds? If there are, we need to adjust this name to reflect the number and location of the pi bonds. There aren't in this case, so we'll skip over this, but we'll come back to it with another example. All right. Let's deal with the prefixes. What other functional groups haven't we accounted for? That ketone. So a ketone is lower priority than a carboxylic acid, so the location of the ketone is going to appear in the prefix, which gives us the identity and location of all other groups. What is the appropriate prefix for a ketone? Oxo. Good. Interestingly, that's the same prefix for an aldehyde. And you might wonder, how can I tell a ketone from an aldehyde? Don't worry, we're missing one last thing, and that is we got to use numbers to describe where everything is. If the oxo were on carbon 1, it would be an aldehyde. If the oxo is on any carbon other than carbon 1, it's got to be a ketone. But maybe that'll become clear later. Okay. So we've identified the highest priority functional group. We've considered the number of carbons in the longest chain, identity and location of all other groups. Now we need to choose a numbering scheme. Because it's not enough to say, yeah, this is a butane oic acid and there's an oxo group in it. We have to have enough information where our name will tell us exactly where all of the groups are. The standard is your name, the name for this molecule, must unambiguously describe the structure so that if all you had were the name, you could draw the molecule and get it right. So we start to choose a numbering scheme. Carbon number 1, start with the highest priority functional group if possible. If not, choose to start at the end of a chain, at the chain end, that gives the highest priority functional group the lowest possible number. All right, so in this case, our highest priority functional group is the carboxylic acid. The other principle is I'm going to choose a numbering scheme such that the most groups have the smallest numbers. You'll see what we're talking about here in just a second. So the highest priority functional group is a carboxylic acid, but I could start numbering 1 here, 1, 2, 3, 4, or alternatively, I could start numbering here, 1, 2, 3, 4. What's the right way to do this? First one, why? Because then I could give the ketone number 2 instead of number 3, right? So that's what I'll choose. I'll choose the blue, 1, 2, 3, 4. Then, before the prefix for the ketone, I'm going to write the number that that ketone appears on, which in this case would be 2. 2-oxo. All right. Next, I need the location of the carboxylic acids. If there was only one, I wouldn't need a location because it's implied in the name carboxylic acid. The carboxylic acid has to be at the end of a chain by definition. Since there are 2, I have to indicate that there are 2 carboxylic acids and that they're on carbons 1 and 4. So before the oic acid, I'm going to put 1, 4 dash, and then I need something to indicate. Those are 2. Go ahead.
I just was wondering, because like when you are writing out the structure, it's okay, it's butane, you have a ketone on carbon number 2, and you say like that it's dioic acid, so it's going to be 2 carboxylic acids.
Right.
Could you just not put 1 and 4 because that would, like, it kind of imply that they would be on the end
So could you leave out the 1 and 4, because if you just called it 2-oxobutane dioic acid, could someone figure it out?
Like
Maybe.
It's the same as like the
Maybe.
aldehyde, like the
Right.
oxo-
Could you do that? I don't know. I actually don't know the rule there. I think you would, as I said, if there were just one carboxylic acid, it's a no-brainer.
Yeah.
You don't need the 1. If there are 2,
Because you're your diet.
right. So it's probably okay to leave out the 1 and 4. I'm going to put it here for completeness. One thing you absolutely need is the di root. Sorry, we're in the suffix. We need a pre-suffix prefix. Something to go immediately before the suffix. Whatever. You use the Greek numbers di, tri, tetra, penta, and so on to talk about how many of each group you have. So in this case, that's dioic acid. So put it all together, we would simply call this molecule 2-oxobutane, and sometimes people drop the E. You can keep the E or drop it either way. 1,4-dioic acid. Or if you want to have it be more pronounceable, you call it oxaloacetate. All right? Yeah.
I have a question. Can you put the dioic together with butane instead?
Yes. Could you? There are some alternatives to this, and it's mostly a matter of style. There's probably rules that govern it. I don't particularly care. 2-oxo, you want to call it. We could do 2-oxo-1,4-butane dioic acid, like that. And that's fine. If you need numbers to refer to the highest priority functional group, you sometimes have to use your best judgment about where to put the numbers. The key principle is to avoid confusion. So, for example, here, in either of these names, there's absolutely no confusion about what the 1,4 refers to. It refers to the dioic acid. If we had double bonds in this molecule, pi bonds between carbons, we would need to adjust this name and indicate the location of the double bonds, and there we would want to avoid confusion between the location of the double bonds and the location of the highest priority functional group. Okay? So why don't you try one on your own, see what you can do. This is, do we have one today? Do you have one on your quiz? Today's quiz 4. Oh, I'm looking at quiz 3. So yeah, why don't you try isoleucine? Yeah, go ahead.
Could you explain what a ketone came first in the name?
The question is, why did the ketone come first in the name? Yeah, the highest, it seems backwards, doesn't it? The highest priority functional group gets named last, and that's the root name of the molecule. Yeah, the less important stuff comes first. Yeah, so this is backwards from what Stephen Covey taught us, which is the most important stuff comes first, but, whatever. Okay, yeah, to quiz 4, why don't you try the first one. This one has a non-standard name, isoleucine. And that's what you'll call it, but for now, let's figure out its IUPAC name. Okay, far enough along, you ready to compare with a friend? No, still working on it? All right, well, keep going. Recruit a friend when you're ready. Don't be afraid of making mistakes. The best way to learn this is just to get a ton of these wrong and then understand why. Yeah. Other questions? Need help on your process? All right, anybody want to walk us through? I'm having a hard time gauging how you're doing. Are you still like in the middle of it, or are we basically done? Or we're stalling for time because you know I'm letting you out in 5 minutes? Okay, anybody want to walk us through it? Anybody brave intrepid souls? Yes. Was it Annika, is that right? No. Yes, oh, okay. You've been with us before. Take a shot. Do not throw away your shot.
Is it already on the pen? How does this
Oh,
work?
no, you're on the laser pointer. There
Okay.
you go. Amino 3 methyl 3-methyl pentanoic acid.
So for this, I started counting at this carbon right here because this is the carboxylic acid functional group. So it's 1, 2, 3, 4, 5, and a carbon chain of 5 is going to have the root of pentane.
Yep.
And because carboxylic acid, the suffix is going to be the oic acid. Oh, whoops, just erased it. Anyway, and then on this second carbon right here, we have the amine group, and so 2 amino, and then right here is a methyl group, so 3 methyl. And that's all I did.
Good. Any questions or alternatives or worries? Yeah.
We also say 2 amino 3-methyl pentane 1 OH acid.
Yeah, so could you also say 2-amino 3-methyl pentane 1 oic acid? Yeah, that's not wrong. It's a little bit redundant because there's no other way to interpret it if you say pentane oic acid.
So you don't need the 1.
You don't need the 1. If you put it there, it's not wrong. So yeah, let me write that out alternative. And thank you, Annika, for that. I'm gonna just add the L on methyl, or else I'm gonna be worried about that. Yeah, the question was, could you do everything the same except pentane 1 oic acid? And if there's just 1 carboxylic acid, you don't need the 1, but if you put it there, it's not wrong. The standard on these questions is, does the name give you the right structure? Not, did you technically get all the rules right? Okay, technically by the way, there is a rule for in what order you should put the prefixes. You'd think it should be in numerical order, and that would make sense, but that's not the rule. You put them in alphabetical order. But that just happens to work out to be the same thing here. That said, I don't care about that alphabetical order rule, because whether I call this 2-amino 3-methyl pentanoic acid or 3-methyl 2-amino pentanoic acid, you're going to get the right structure. All right? Okay, let's do this one. Oh, hold on for a second. My son is calling me because he's trying to find where Amber's supposed to be. I will just call him back in a second. You going to write to the administration about me taking a call in the middle of class? Yes? Okay. Oh, he hung up anyway, so, all right. All right. We have time to start on one more. Highest priority functional group on this one is what? Aldehyde. So the suffix for aldehyde is al, or all, however you want to pronounce it. 2, 3. So the root should be propane. So propanal. You don't need the 1 because, of course, in an aldehyde, it's obvious that the highest priority functional group's on carbon 1. All we need to do then is think about the other groups. And those are on carbons 2 and 3. Because there are 2 of them, we will write dihydroxy. 2,3-dihydroxypropanal. We don't do 2-hydroxy, 3-hydroxy. We do 2,3-dihydroxy. All right, and the last one, I'll maybe write that one down in your notes. I'll give you that one as an exercise to do before next time. You're also prepared now for, I think there's a question on this. Yeah, there's a couple of these on problem 8 of your problem set. Okay. So I'm getting nervous since my son Dallin's been calling me. He gets to be out of school this afternoon to go hear his mom's talk over there. So we'll go ahead and finish up. I will see you on Monday. Your problem set's due Monday. You should be able to do all the problems on them now. And I will see you then. Have a good weekend.